Hello, I'm Aditya Anugu, and this is the Mass of a Black Hole lab. The goal of this lab is to calculate the net force that acts upon a black hole of an unknown mass, which will be solved for by a star with an unknown mass in a simulated model. We're interested in this because we can learn that the forces that create the changes in momentum are not visible or directly measurable, but can be found through observable changes in momentum of objects. The main fundamental principles used in this lab mainly come from Newton's momentum principle, which states that the net force of an object is going to equal its change in momentum over time. In this simulation, we can use the momentum principle to state that the sum of the components of momentum will equal total momentum at any moment, which can be used to find F net. Essentially, we can say F net is equal to the sum of the parallel and perpendicular components of momentum divided by time. Afterwards, F net can be related to the mass of the black hole by assuming the only force acting on the black hole is gravitational force due to the gravitation from the mass of the star. We can essentially say F net is going to equal the gravitational constant times the mass of the black hole times the mass of the star divided by distance squared. This equation can be rearranged to find the mass of the black hole, which would be equal to F net times distance squared divided by the gravitational constant by the mass of the star. Hence, the momentum principle alone is sufficient to find the mass of the black hole, as well as the net force the star applies on the black hole. In the simulated model, here are the references used, and here is the code used for the model. Here's the actual model itself. As you can see, when we run the program, there is a perpendicular and a parallel component of F net, and F net is represented by the orange arrow, which is the sum of both those components. Then after the program is run, we are returned F net parallel, and F net perpendicular, as well as the calculated mass of the black hole for every point of time. Here are the results returned by the program. The average mass of the black hole would be 7.38 times 10 to the 33rd kilograms. The average mass was calculated by taking the mass at every point of time and dividing it by the number of masses returned. Considering that the program only returned the calculated mass of the black hole at every point of time, so we have to calculate the average mass ourselves. Whereas the program does return F net parallel, and F net perpendicular, which can be seen here on the slide. This is essentially how the program works. As mentioned in the fundamental principle slide, the perpendicular and parallel components of force make up the F net. The parallel component of force is found by multiplying dp dt by the unit vector of momentum, which can be seen in these lines here. Then the perpendicular component of force can be found by subtracting the parallel component from the total force, which can be seen here. Then, the mass of the black hole can be found using the equation derived on the fundamental principle slide, which is right here. Finally, the arrows for the perpendicular and parallel components of force, as well as the total force, will be drawn on each point of the orbit, which is shown in these lines of code. Now we're going to go over the "what does it mean" question. F net and its components are different from the rate of change in momentum and its components because rate of change in momentum and its components are observable changes that depict how an object in motion would change its motion, whereas F net and its components are the causes for those rate of changes in momentum and cannot be directly observed. Finally, we'll go over the "what if" question. If the black hole was replaced by another one with a different mass, you can tell the difference based on the rate of change in momentum being different than the previous rate, considering that the star would exert a different force on the black hole, and F net is directly related to the rate of change in momentum. It is possible to find a new mass of the black hole by using the same formula previously used to find the mass of the first black hole, which is mass of black hole is equal to F net times distance squared divided by gravitational constant divided by mass of the star. This is essentially the gravitational force formula rearranged for the mass of the black hole because it is assumed that the only force acting on the black hole is the force of force due to gravity of the mass of the star. Thank you for watching.